Let's now consider a given moist air that is being heated up or cooled down. When a given air is only heated or cooled, there is no mass transfer, so the proportion of the different constituents of the air does not really change. So let's first talk about moisture that is heated. If the moisture is heated, so the molar fraction of dry air and of water is not changing, so it means that if the total pressure is not changing, the partial pressure of dry air and of water vapor are constant, so the moisture content is also constant. When the moist air is heated, the temperature of the moist air is increasing, and because the temperature is increasing, there's an error here. The saturation pressure of water is increasing too. And when the saturation pressure of water is increasing for a given moisture content, then the relative humidity is decreasing when the moist air is heated. Let's now consider a moist air that is cooled down. So similarly, we can describe the first phase of cooling for which the moisture content is also constant for the same reasons. In that case, when the air is cooled down, the temperature is decreasing, and because the temperature is decreasing, the saturation pressure of water is also decreasing. And when this saturation pressure is decreasing, the relative humidity is increasing. And this cannot go forever because this will go until the relative humidity is equal to saturation, so is equal to 100%. That's happening at the temperature that we called the dew temperature. Why the dew? Because it's exactly the same thing that is happening when dew is depositing on cold surfaces at night. So what is happening when we reach saturation? In that case, it's not possible anymore to continue to keep the same partial pressure of water at a value that will be over the saturation pressure of water, because the water will be oversaturated. So in that case, the water vapor that is present inside the moist air will start condensing. So either it will condense as a film on surfaces if the moist air is cooled by surfaces, but if it's cooled in volume, it will give rise to the presence of a suspension of droplets inside the air. So it's like a fog or like a cloud, and there will be the presence of a liquid and of a vapor phase concerning water. So from a thermodynamic point of view, if we have equilibrium between the liquid and the vapor phase of water, it means that necessarily the partial pressure of water corresponds to the saturation pressure of water. So if we continue cooling down the moist air, once we have reached the dew temperature, so at saturation, we have a second phase for which we keep being at saturation. But if we stay at saturation, we have part of the water that was previously inside the water vapor and that was taken into account in the moisture content, that will now be in the liquid phase, and so that will not be taken into account in the moisture content anymore. So when we continue cooling down the air, the moisture content will decrease and the temperature will also continue decreasing.